All right, so taking a quick peek at this page 29 of your packet, this is the 4.6, and this is looking at a function and its inverse, and then how the domain and range is affected between the two. So look here on the left, this is my little work for the inverse, or f of negative 1 of x. So I don't know if you have your notes with you, if you remember these steps, so here they are at the top in case as well. But the steps for finding the inverse are going to be as follows. We need to do the definition of inverse, switch x and y, and then solve for that y, and then put it into function notation, f of negative 1 of x, okay? And so on all of these, you'll see that work over here to the left. Then you're going to go graph this in Desmos, graph x squared minus 1, and then graph the inverse, square root of x plus 1. So if you take a peek at this first graph, here we go. So the first graph, x squared minus 1, that's my typical parabola that's down 1. And then we go out 1, up 1, out 2, up 4, etc. Right? Here's my regular parabola. Then I graph its inverse, and I see that it's essentially a sideways parabola where I can't go below 0. So it's like only half the parabola. And why can't I go below 0, by the way? Because we can't have negative values under a square root, and this is a square root function. And so I also want to just put in the line of reflection for you real quick, y equals x. Do you see how it just splits that straight down the center? The line of reflection is taking the red parabola and reflecting it over that same y equals x line. And so you're going to recreate this graph over here on page 29 by finding a couple of anchor points. Always remember to put this line of reflection in here. And so you can either do the same as me, do it in Desmos and paste it in here, or just like we did in class, you're going to put the points on this graph yourself by hand. So here I go. I'm going to go ahead and put this guy in here and then size it. I didn't realize that it was going to affect this line. Okay, so there's my graph. So you can either create the graph and then draw on that line of reflection, or you can create it in Desmos and paste it in here. Next one is a linear function, 3x plus 2. So we switch x and y, minus 2 to both sides, and then divide by 3. We get another linear function, x minus 2, or 1/3 of x minus 2. And then we're going to go over here into Desmos, graph your first linear function, put in the inverse function, the blue one, and then don't forget that line of reflection. It goes straight down the center. So a linear function creates a linear inverse. And then there's our line of reflection down the center. So again, go graph this yourself. Graph 3x plus 2 with a couple anchor points, or you can do the same as me and insert the graph from Desmos. All right. Now notice that on linear functions, the domain goes forever left, forever right, negative infinity to infinity, and the range goes forever down, forever up, negative infinity to infinity. And so the inverse is also linear. So it goes domain, negative infinity to infinity, and range, negative infinity to infinity. All right, next guy is a x plus 3 squared function. It's another quadratic. So we're going to have a U-shaped graph, and then we're going to have its inverse, which is going to be a sideways U, but only part of it. The domain of any parabola is negative infinity to infinity. And then the range of that parabola is going to go from the 0 up. And our domain and range of the inverse and the regular function, you're going to notice are going to match. But so let's go plot these 2 points, these 2 functions. X plus 3 squared is the red function. There's our parabola. And then root x minus 3, there it is. Don't forget to put in y equals x. And then I'm going to screenshot that in right here. Do the same on the last one. You can either create it with Desmos or not.